we have just seen that presence of electron withdrawing groups by inductive effect have an important effect on their acidity, and that's by additional inductive withdrawal, which would result in delocalization of the charge or electrons, which results in stabilizing the conjugate base more, and therefore the acidity of the original carboxylic acid is actually enhanced. Not only the presence of electron withdrawing groups that has an effect on the acidity of carboxylic acids, it's also the distance. So the relative distance between the electronegative atom or the electron withdrawing group by inductive effect and the carboxylate unit itself. The closer the distance between the electron withdrawing group by inductive effect and the carboxylic acid unit, the more acidic the carboxylic acid will be. That's because the inductive effect would be stronger to delocalize the charge or electrons in the corresponding conjugate base, which would then result in stabilizing the corresponding carboxylate further. So let's take examples. So this is butanoate, but this butanoate has a fluoro group on carbon number 3. So this is 3-fluoro-butanoic acid. Let's take 2-fluoro-butanoic acid, which is this one. So 2-fluoro-butanoic acid. We can draw the corresponding conjugate bases, and if we do that, we would get something like this. So this carboxylate for the 3-fluoro-butanoic acid, and this carboxylate for 2-fluoro-butanoic acid. We can delocalize charges or electrons in exactly the same manner that we did generally before on carboxylates in order to explain acidity of carboxylic acid. So we can do resonance withdrawal or resonance stabilization of the conjugate bases. So we get something like that on that carboxylate. As a result of this resonance stabilization, we can do something similar here to get another resonance form. So both of them are stabilized by the same resonance effect, if you like. But if you look at that carboxylate has a fluoro group on carbon number 3. So there's an inductive effect. The fluoro group being an electronegative atom, in fact, the most electronegative atom, pulls electrons toward itself in this C carbon fluorine bond, leaving carbon with a positive partial charge and fluorine with a negative partial charge. So there is an additional inductive withdrawal. But this carboxylate has also the same group. So fluorine also pulls electrons toward itself in that carbon-fluorine bond, leaving carbon with a positive partial charge and fluorine with a negative partial charge. So there is also an inductive withdrawal. But this inductive withdrawal is actually stronger than that inductive withdrawal, or this inductive effect is stronger than that inductive effect. That's because it is closer. This inductive withdrawal is closer to the carboxylate. Therefore, its withdrawal ability will be much more efficient. Its ability to withdraw electrons or the negative charge on the carboxylate would be better. And this would result in better or greater stabilization of the conjugate base. And therefore, the 2-fluoro butanoic acid is actually more acidic than 3-fluorobutanoic acid. So if you like, we can summarize this as closer inductive withdrawal here. So there is closer inductive withdrawal. That's because the fluoro group is on carbon number 2, whereas the fluoro group here is on carbon number 3. Again, this closer inductive withdrawal results in better delocalization, or better or stronger delocalization of the charge, the negative charge, obviously, of electrons. Now this results in stronger or better stabilization of conjugate base. If the conjugate base here, or the 2-fluorobutanoate, is more stable than 3-fluorobutanoate, therefore 2-fluorobutanoic acid is more acidic. 2-fluorobutanoic acid is more acidic than 3-fluorobutanoic acid. That's because of the stronger inductive effect, because of the closer distance between the electron withdrawing group and the carboxylate. So the point of this is actually the distance between the electron withdrawing group and the carboxylate unit. The closer the distance between the electron withdrawing group by inductive effect and the carboxylic acid unit, the more acidic the substance will be, or the more acidic the carboxylic acid would be, because then the carboxylate would be more stable and more stabilized by the inductive withdrawal, because of the proximity between the electron withdrawing group and the carboxylate